So this video is about similar figures. And similar figures, the thing that's really important for us to understand is that they are the same shape, but they are two different sizes. So for instance, these two triangles are similar figures. They are both acute triangles. They look like they are generally the same shape, but this one is big and this one is little. Now, the cool thing about similar figures is that the sizes are proportional. And when you hear the word proportion, you should think ratios, because you've learned how to solve a proportion by, you know that proportions are made of two ratios, and you can solve those by cross multiplying. All right, so let's talk about the different ratios here. I've got this side AB that goes with this side DE. So I can, hang on. Didn't mean to do that. Meant to do this. This side AB goes with this side DE. And you're going to see on these videos, I like to color the sides that go together the same color, because that really helps me be able to associate the sides with each other. BC is going to go with EF. When the figures are drawn so that they're sitting the same way, basically, it's pretty easy to tell which sides go together. But when the figures are drawn so that they're flipped over or rotated around, it's a little bit harder to figure out which pieces go together. So sometimes coloring them in is helpful like this. Okay, so now I can tell which pieces go with which. So I know the 10 should go with the 20, so 10 over 20. I know the 6 should go with the 12, so 6 over 12. And I know the 7 should go with the 14. And the way you can check to see if figures are similar or not is you can check all of their ratios to see if they're the same. Well, 10 over 20 reduces to 1/2. You can just type that into your calculator, 10 divided by 20, and then hit the math button, and then hit enter twice, and it'll give you a new fraction, 1/2. 6 divided by 12 reduces to 1/2. Hey, look, they're the same. And 7 divided by 14 reduces to 1/2. Because all of these ratios are the same, that proves that these two figures are similar. All right, another thing that we need to be able to do with similar figures is we need to be able to write a similarity statement. So for instance, if I called this triangle BAC, so I'm going to write BAC is similar to blank. All right, B is where the purple and the green lines met up. So in this figure, where the purple and the green lines meet up, that needs to be the first letter in this triangle's name. So the first letter here would need to be E. I'm just going to switch colors. Needs to be E. A is the middle letter, and A is where purple and pink meet up. Well, where purple and pink meet up down here is D. So D will need to be the middle letter over here. And then the last letter here is C. C is where pink and green meet up. So where pink and green meet up over here is F. So F will need to be the last letter over here. You will need to be able to both write a similarity statement and use a similarity statement to figure out which pieces go together in a figure. And we will do that in the first example video.